My name is Natalia Permякova. I am a medical statistician, and I'm going to talk about writing statistics sections. So I thought I would start with this quote as it sums up pretty well my whole experience of working as a statistician at the Research Support Service. If the research question and objectives are clear, the design, sample size, and analysis plan will flow from them. You may expect that a statistician is going to be interested only in calculating a sample size and writing an analysis plan, but you may be surprised when a statistician keeps asking you questions about your research question aims. The role of a statistician in a grant application is wider than you think. Power calculations and statistical analysis plans are a relatively small part of the role that a statistician can play in the preparation of a high-quality, competitive grant application. The broader role of a statistician is to question, to listen, and to think, and to partner with researchers to enable the highest quality research. A statistician can piece together a picture of the research that is being proposed and identify the weak or missing links. For example, they can question about how will that intervention really work, or what has been overlooked. To get useful advice from your statistician, including that important sample size calculation, you need to know what your study design is, which actually the statistician can also help you with. So let's have a brief look at them. All the study designs on this slide are of a theological nature, meaning that they focus on cause and effect. But the big divide is between observational, in other words, non-experimental studies, and intervention, in other words, experimental studies. There are advantages and disadvantages of each type of a study design. For example, if you want to compare a drug to a placebo, you would run a clinical trial as an experimental study. But if you wanted to run a study that monitors the growth of children from birth for 10 years and the factors that might influence that, you might run a cohort study as one of the types of an observational study. So in observational studies, you are not intervening, but just observing. The funding panel will expect explanation for why you chose this study design. So you need to think together with the statistician about the questions like, has a clear rationale been provided for the study design? Have patients, service users, carers, and relevant stakeholders been involved in the design? Why this design is the best suitable for your study? The other big thing which the panel will expect is a clearly justified sample size calculation, which is dictated not only by the study design, but also by your research question, which we will talk about in the next slide. To calculate a sample size, we first need to understand what question you're trying to answer. Ideally, this question will clearly state the primary outcome of interest. And if not, a statistician is going to ask you about it. The type of question we're asking dictates the broad type of sample size justification we will carry out. Two common types of questions are descriptive and comparative, and can arise in both experimental and non-experimental study designs. So a descriptive question aims to describe a certain parameter of interest rather than compare some groups. So for example, what is the prevalence of sedation in critical care units? What is the association between self-reported and measured physical activity? You can use a descriptive question in a pilot study with a clinical trial design. For example, if you want to know the recruitment and dropout rates before running a full trial, and such study will be called a feasibility study. On another hand, a comparative question is going to look at differences between groups by comparing one group to another. For example, the research question will be like, is a strengthening and stretching program for people with rheumatoid arthritis better than current care? Or, for example, is drug A better than drug B? And we will now look at what you need for the sample size calculation for each type of research question. So let's start with the descriptive studies first. To calculate a sample size for a descriptive study, a statistician will need to know about the analysis you are most interested to perform in your study, which should be clear from your research question. And if not, a statistician will help you to clarify it and phrase it correctly. So like on the previous example, if your descriptive research question is about the association between self-reported and measured physical activity, then a statistician will advise you to look at the relationship between these two variables by analyzing a correlation coefficient between them. A correlation coefficient will then be the statistic of interest. For the actual sample size calculation, you will need to decide on its planning value. Note that the sample size for descriptive studies are precision-based. Therefore, you need to decide on the level of precision that you want. So let's talk about what is a planning value and precision level in the next few slides. To know how many people you need for your descriptive study in order to have a reliable estimate of the correlation or proportion of interest, you need to have some prior information about the value you might expect, based on which you will then build your precision estimates. You would mostly rely on previous literature, or you could run a pilot study prior to your main descriptive study. If nothing is available to use, you could come up with the worst case scenario to ensure that the precision is no worse than some desired level. So let's talk about precision on the next slide. So what did I mean by precision all this time? It is essentially a confidence interval with a low and upper limit, which defines an acceptable level of precision around your planning value, with the precision of, for example, 99%, 95%, or 90%, but usually 95% is used. Confidence interval of 95% is the range of values you expect your estimate to fall between if you redo your test 100 times with a 95% level of confidence. We will look at the example of precision-based sample size calculation in the next slide. But remember that the choice of the width of the confidence interval should be justified in your grant application, which is usually clinically driven to draw meaningful conclusions from your sample. A statistician would usually come up with a range of scenarios of the precision-based sample size calculations, depending on the planning value and the desired confidence interval width. This example on the slide is based on the proportion as a statistic of interest. If, for example, some studies suggest a proportion of 0.3 or 0.5, then you could identify different sample size scenarios depending whether you would want a more precise or a less precise estimate. The narrower the width of the confidence interval, the more precise the estimate is, and the bigger the sample size is. For example, if you narrow down the width from 0.2 to 0.1, you would need to increase your sample size by almost 3 times. To choose the sample size from these scenarios, you need to think about the next questions. How much does it matter to you to have a wider range of values estimated around the expected value? What width will be clinically meaningful? What number is realistic to recruit for your study? Now let's look at the sample size calculation for comparative studies. In order to do a sample size calculation for a comparative study, a statistician needs to know about the type of study design, the effect size, a measure of the variability, the desired power level, and the desired significance level, which is also known as the type 1 error rate, and it is usually taken at the 5% level. We will talk about each one of them separately on the next slides, but you can already see that a lot of considerations go into how you can calculate the sample size for comparative studies. And that is why it may seem like statisticians have a lot of questions to you at the start of writing a grant application. Let's start with the study design. Many comparative research questions are asked within experimental study designs, in particular in clinical trials. However, you could also do a power calculation for an observational study if you cannot randomize the participants. There are many issues relating to the design of a trial that can affect the sample size calculation. For example, the number of groups you will have in the study, and whether you will have repeated measures on the same people or whether the groups will be independent. Also, the type of primary outcome for the study is very important because the sample size calculation will be completely different for continuous, categorical, or survival outcomes. If your study is going to be a trial, then the type of randomization would also need to be accounted for. Whether you randomize only patients or, for example, the GP practices to adjust for the expected correlation between patients within the same practice. Next, I would like to talk about the effect size, which is essentially a numeric value of the difference between the groups which you expect to find in your study, and it is expressed in the units of the primary outcome. In a well-designed study, this is equivalent to the effect of the intervention or behavior of interest. So why do we need the effect size? Well, should this effect size exist, we want a good chance of ruling out there being no effect. So in other words, if we observe this difference in our study, then we want to be able to say that the result is statistically significantly different. In case of clinical trials, the choice of the effect size for sample size correlation should be the minimum clinically important difference, which we will talk about in the next slide. So how would you know which value to go with for the effect size of your study? For sample size calculation, effect sizes are not what you hope or expect to see, but is a minimum effect size which will change practice. You will first look at the previous studies related to your field of research, but you will also talk to clinicians about the smallest value that will lead to a change in practice. So, for example, if you have a primary outcome of the cancer-related quality of life, someone might have already established the minimum clinically important difference in this outcome by finding that a minimum change of 10 points in the score is clinically meaningful for patients with certain type of cancer after treatment in comparison to their baseline score. In certain areas of research, people have done work on different outcome measures to define the minimum clinically important difference. So you should definitely check this when designing your study. Otherwise, this is a decision for the clinician. In certain situations, a statistician might help with a more generic approach that does not require clinical judgment or previous literature, but you need to discuss it with your statistician and make sure that it is in context for the condition you're looking at and what this would actually mean for the patients. However, remember that it is your responsibility to choose and justify the effect size for your study, and it is not the statistician's responsibility. So let me explain how the effect size affects the sample size. Larger effect sizes leads to requiring less people. It is a bit of a Goldilocks situation. An effect size that is too large may also raise suspicions that you are uncertain about your ability to recruit. It is rarely sensible to adjust the effect size purely to save numbers. The smaller the effect chosen, the larger the sample size will need to be. This is why it is important to select the minimum clinically important difference for your study. A bigger difference will lead to a smaller sample size requirement and may mean you cannot show a smaller difference than this to be statistically significant. You don't want to get to the end of the study and say, well, we saw a difference of, say, 2 units between the groups. This would make a huge difference to patients' lives, but we used a difference of 5 units in the sample size calculation, so we don't have enough people to show the difference of 2 units to be statistically significant. So as a result, our finding looks negative. The next important factor for the sample size calculation is the variability of the outcome measure. When talking about continuous outcome measures, it is most often mentioned as in the standard deviation or the variance. As for the binary outcomes, it will be then the rate or proportion. You can get an estimate of this from previous literature and studies in a similar area. If you have a lot of studies to choose from with different estimates of the variance, then you should choose the study with the best quality in terms of the sample recruitment and retention. Remember to consider carefully how similar your population is to the population you're using to estimate the value. If there is a lack of literature, then you could also consider conducting a feasibility or pilot study to find variability for the main study sample size calculation. Lastly, if neither of those options are available, a statistician can help you to apply a generic approach. But again, you need to make sure that you put this into context and justify why this is the best choice. It is important to know that a larger variability leads to requiring more people. If patients in the population of your interest are more different from each other, for example, a wider range of age, that means that your data are likely to be more scattered and you will need to have a bigger sample to see what is going on in this population. Therefore, you will need a larger estimate of variability. By relying on previous studies, if you have several high-quality examples close to your population of interest, you could combine the estimates of variability across those studies. Apart from this, you should also think about generalizability. For example, can you then apply your results to this population in practice? Is your sample likely to be representative with the estimate of variability you consider? Let's now talk about power and error rates. When we use the significance test to make decisions about whether to accept or reject a null hypothesis, we can make two types of errors. We can either reject the null hypothesis when it is in fact true, or we can fail to reject it when it is actually false. These are often labeled as type 1 and type 2 errors. Imagine you're trying to hunt a lion. Type 1 error is when there is a kitten outside, but you see the lion. So type 1 error is when you find that something is going on when it is actually wrong. What you equally do not want to have is type 2 error. Imagine there is a lion outside, but it is okay, it's just a cute kitten. Both types of errors need to be controlled in your study to a level at which we are willing to accept. Conventionally, power is set at either 80 or 90%, and type 1 error is usually set at 5%. So if the null hypothesis is false, then we can either reject it, which will be the correct decision, and this is often referred to as the study power, or we can accept it, which will be a type 2 error. So for example, you might accept 20% that you get that lion or kitten wrong, and then the power for your sample size calculation will be 80%. So it is 100% minus 20%. Sample size calculations are not a crystal ball, they're just an estimate, using which you will show to the funder and audience that you try to be as precise as possible. So here is an example of a range of scenarios of the total sample size required for a study, focusing on the effect size of 0.3 or 0.4 for their primary outcome. Notice how a higher effect size required less people to recruit. However, the estimated sample size won't guarantee you that you will recruit so many patients. It is only an indication of power and variability. It is your responsibility to know the required recruitment period of time and the number of sites required to recruit the estimated number of patients. The statistician will also talk about it with you to make sure that the estimated sample size is actually realistic for your study. For example, notice how this range of scenarios accounts for the potential dropout of patients over time after the recruitment. In the next slide, I will talk about other common considerations for the sample size calculation. Beside the dropout rate, other considerations would include the type of follow-up and the type of censoring. If, for example, you focus on survival data, like death or progression rates. If you have patients clustered with GP practices, then you would need to account for the intra-cluster correlation and the number and size of clusters themselves, which will be the GP practices in the example. Just a reminder that when using an observational data for comparative research questions, Be aware of confounders if anything is causal in the research association, which you might also need to account for in your sample size. A statistician can help you with all these decisions, and you might need several meetings to be able to provide your statistician with more information on the population of interest, your research question, the sites you could recruit, and so on. For example, as already mentioned, you need to decide on the realistic recruitment period and the number of sites you can recruit for your study. The funding panel will expect to see that the proposed recruitment is likely to meet the targets and that you have already consulted patients, carers, and service users about the best recruitment process for your study. You will also need to think whether the process you propose of accessing, approaching, consenting, and enrolling potential participants is actually ethical and suitable. For example, for your population of interest, the health condition of your study, or with the current NHS workload. Now let's look at a case study of how to put your statistical aspects of the proposed study together for an NIHR grant. Our case study for today will be the NIHR Health Technology Assessment Program call. The full information is presented on the right of the slides, but to save our time reading this, I will point out the most important aspects of this call, which a statistician will need to know about your study. So the aim of this call is to evaluate the clinical and cost effectiveness of physical exercise for treating depression in adolescents. You might have already heard about PICO, which stands for 4 words describing study population, intervention, comparison, and outcome. In this call, the population of interest is adolescents, the intervention is physical exercise, the comparison is no exercise, and the outcome is the measure of the depressive symptom severity. Moreover, this call requires applicants to submit plans for a 3-arm study to evaluate separately high and low intensity physical exercise compared to no exercise. It also needs to be a randomized clinical trial. So as I go through the various steps involved in putting the stats components of your application together, I will refer back to this case study to illustrate the points that I'm making. But the points that I make will generally be transferable to other types of health studies, whether a clinical trial or an observational study. This is an example of what statistical aspects you would mention in your plain English summary and scientific abstract. So in the plain English summary, it needs to be written in simple language about how many participants you aim to recruit. So in other words, your calculated sample size. However, the scientific abstract should go into more details about the chosen clinically important effect size, the variability, power rate, and the significance level, as well as any other sample size considerations like the dropout rate. So in this case, the final sample size was 387 participants, which was based on the effect size with a value of 2, which was the difference in the means between each exercise arm and no exercise arm. The variability around the estimate, which was the standard deviation of 4.4. The statistical power of 90%, meaning that the type 2 error was chosen at the 10% level. The type 1 error of 5%, which is the significance level, and the dropout rate over time of 20% of the recruited participants. However, you would need to go in even more details about the statistical plan in your research plan of the grant application. Simply put, just saying the total sample size is not enough. You need to explain why you chose certain parameters in your sample size calculation, like the effect size of 2 in our case study, or the dropout rate of 20%. You need to justify the chosen sampling methods and why they're the best fit to your research question. The sample size calculation should be explained in such a clear way that it could be verified by another statistician on the panel. So please do not delete or condense any information the statistician provided for your study, as it will then jeopardize your chances of getting a grant if a panel cannot understand how you came up with the total sample size. Now let's look at this example of how ideally you would have the sample size calculation paragraph written on the example of our case study. I will start to highlight certain areas in this paragraph to point out the most important aspects. So first of all, you need to remind the panel about your primary objective. In this case, comparing two intervention arms to the control arm. And usually in the same sentence, you need to remind about your primary outcome or co-primary outcomes if you have more than one. You should also indicate the endpoint at which you collect the primary outcome after you recruit the participants. You can then repeat the same information which you used in the scientific abstract, but now add the references to the previous studies which these parameters were based on for your sample size calculation. And of course, do not forget to mention any other considerations you had for your final sample size, like the dropout rate. Finally, you need to show that you're aware about the realistic expectations for the recruitment of patients into your study in terms of its rates, length of time, and number of sites, which would allow you to meet the total sample size target. In our case study, for example, you expect 9 eligible patients per month over the total of 18 months over 10 sites. So there is a lot of information the statistician needs in order to put that paragraph right in the research plan section. Moreover, you should allow the word count of your grant application to include more details on different sample size scenarios which were considered. For example, because of the variety of recommended effect sizes, which you of course need to back up with the previous literature, and your justification of the best suitable effect size for your study. Remember that the most common problems which panel members come across are that the sample size calculation is based on a continuous outcome when the primary outcome is in fact binary, or that a wrong study design was chosen, or the within group comparisons rather than between group comparisons. That the estimated treatment effect is too big and clinically unrealistic, or that the sample size is too big to be feasible within the time frame, or that the research team has not taken into account dropouts or treatment crossover. Talk about the analysis plan. Statistician can write this section for your grant application too. However, you will need to think together as a team whether the proposed analysis plan is clear and suitable for your data and research question, because this is what the panel will be looking for. The first thing the panel will be looking for in your analysis plan is that it is consistent with your study objectives and your sample size calculation. So as a reminder, if you are planning to compare groups, like in our case study, then the sample size should be power-based, and therefore the main analysis should be about comparing the groups through a statistical test. But if your research question was about estimating a certain rate, then the sample size should be based on the estimation, so in other words, precision-based. And then the appropriate analysis will be descriptive. So let's come back to our case study on the next slide. So as you remember, the case study has 3 groups comparing 2 types of physical exercise to no exercise. So when you want to explain your analysis plan in plain English summary, you need to talk in simple terms about the methods of assigning the participants to each group, what those groups are, what kind of intervention would they get, and what is the comparison group. You will then need to mention how long is the follow-up period and what will you measure as the primary outcome. However, you should go into more details about your analysis plan in the scientific abstract, where you can use a more technical language. Like, for example, explaining that it will be a trial with multiple centers, with randomization, double blinding, and that it will be a superiority approach by looking at both possibilities of a worse or better outcome than the usual care, for example. Apart from the number of centers and the expected time of recruitment, you will definitely need to say the statistical method which will be applied in your primary analysis and which significance level will be applied. As a reminder, your statistician will make sure that the analysis plan is in line with the research question, the study design, and primary outcome. And you can see a statistician is involved throughout the whole funding application, through all sections. So please be mindful when cutting out words or sentences from your grant application, and always double check with your statistician. Unlike the scientific abstract, your research plan will need to be very comprehensive about your analysis plan, which again will be guided by your statistician. You shall go here in more detail about how the randomization will take place and how the primary analysis will be conducted. You may also go into more details about other outcomes of interest, and you may talk about how you will deal with missing data. Also, mention here about the interim analysis and any specific requirements your study has for certain committees, which will check the quality and safety of your study when it is running. If you have an observational study, do not forget to mention potential confounding variables. Confounding variables are those variables which can lead us to draw a wrong conclusion about the association between the exposure and outcome. Have a closer look at the example on the slide after the presentation, if you have time. To summarize this talk, let's look at common problems in grant applications which it comes to your relationship with a statistician. To take myself right back to the start of the presentation, the sooner you involve the statistician, the better chances your proposal will be successful. You should see a statistician at the start of the project. Ideally, go to see the statistician before you start doing anything. Explain why the research is important and what it is you plan to do. Help your statistician to understand your area of research. For example, provide a list of definitions and acronyms to the statistician in advance of a meeting. A statistician can then have a valuable input into the design of your study and make an early input into the sample size to help the study planning and costs. But to help you with this, we will ask a lot of questions that you will otherwise be asked much later on. Take seriously the time commitment of the statisticians. Leave plenty of time for them to help you. For example, do not send a statistician your whole application last moment asking to fill in the sections about power calculations and analysis plan. Also, changing one part of calculation can lead to rewriting statistical sections, and it is not as simple as just clicking a few buttons. As noted previously, there is still a large part of sample size calculation that requires clinical input. The panel will be looking to see that the analysis aligns with objectives, design, and measures, so removing parts can leave holes that the panel will question. This slide should help you understand how a statistician is going to be involved throughout the research process. As you can see, the statisticians are integrated throughout the whole length of studies, from their development through the setup, management, and closeout, not just by calculating the sample size and writing the analysis plan, but also by attending management and committee meetings and providing preliminary statistical analysis of those meetings, like, for example, for the Data Monitoring and Ethics Committee. And of course, your statistician will help you with the final analysis and dissemination of your findings. Basically, a statistician is a part of your study team whom you need to trust with your data and findings. Some of the points in these boxes might not be relevant to an observational study, but potentially all of these things could affect the costing of including a statistician in your study. So make sure that you appropriately costed in the statistician's help, and that you are realistic about the expected amount of time the statistician will need to be involved in your study. Therefore, in your application, you will need to outline how the statistician will be involved throughout the study. To conclude, firstly, see the statistician before you start doing anything. Remember that certain things might be too late to change later once you receive the grant, so you need to have a statistician's input early on. For example, if you come to a statistician too late, a statistician might want to change things in your study design due to sample size requirements or the analysis issues. This in turn may affect the way data is collected and the number of people you need to recruit, which will in the end affect the cost of your study. To avoid such changes in your study design and costings, you need to liaise with a statistician early on. Secondly, statisticians, even experienced medical statisticians, may have no knowledge of your area of research. There are a lot of terms which are not transparent. It may help to provide a list of definitions and acronyms to the statistician in advance of a meeting. The more we know about the condition, the better our advice will be. Thirdly, we need to know quite a lot about the data. It is not immediately obvious to a statistician just how every clinical variable might be measured. This might be influenced by the state of health of the patient, the laboratory, the analyzer, the person making the observation, the time of day the sample was taken, and even the weather and samples getting held up in the post. Sources of the variation in your data are important to know for a statistician. And finally, remember that a statistician wants to help you. So it is best to make us a part of your team and let us challenge you with questions, because at the end of the day, we want your study to be of high quality and change the practice as much as you do.